How did Rome rise from a small city on the Tiber to shape the course of the ancient world? The answer is written not only in battles, but in stone, water, and roadways that still endure today. Here at Echoes of Civilizations, we explore the structures that carried history forward and the ideas that made them possible. If you value thoughtful journeys into the past, consider subscribing and becoming part of this quiet conversation across centuries. How did Rome become the greatest builder the ancient world had ever seen? The answer does not begin with a battlefield. It begins with a road stretching toward the horizon, with the steady rhythm of boots and wagon wheels pressing into carefully laid stone. It begins with water flowing across valleys in channels of perfect gradient, with bridges rising in calm arcs over restless rivers, and with harbors carved into the coastline to welcome grain ships from distant provinces. Rome did not bind its empire together by force alone. It bound it with infrastructure. Military conquest opened territories, but infrastructure kept them. As Roman power expanded across Europe, North Africa, and the Middle East, it relied on a vast and coordinated system of roads, bridges, aqueducts, ports, and drainage networks that tied distant communities to the capital. These works were not decorative achievements meant only to impress. They were practical instruments of governance. Roads allowed legions to move quickly, but they also enabled merchants, officials, and ordinary travelers to circulate across thousands of miles. Aqueducts carried fresh water into growing cities, sustaining public baths, fountains, and households. Ports received shipments of grain that fed Rome's immense population. Drainage systems turned marshes into usable land and protected urban centers from flooding. Stone by stone, channel by channel, the empire was secured. What made this network remarkable was not simply its scale, but its coherence. The Roman world was connected by visible structures of stone and concrete. Yet it was equally connected by invisible frameworks of law, citizenship, taxation, and shared custom. Infrastructure reinforced these unseen bonds. A road was more than a strip of pavement. It was a corridor of communication and authority. A bridge was more than an engineering solution. It was a statement that Roman order could extend across any obstacle nature presented. Through these tangible works, Rome projected stability and permanence. Many of these structures still stand today, woven quietly into modern landscapes. Segments of Roman roads lie beneath contemporary highways. Bridges built 2,000 years ago continue to carry traffic in parts of Spain and Italy. The massive remains of aqueducts stride across countryside and city alike, reminders of a civilization that believed utility and durability were inseparable. Their survival is not an accident. Roman engineers emphasized careful planning, high-quality materials, and precise construction. They understood that strength created continuity, and continuity sustained power. In this way, the Roman Empire was not only conquered, it was constructed. Its dominance rested on an enduring physical foundation that supported trade, movement, administration, and daily life. The stones of its roads and the arches of its bridges formed a quiet architecture of control and connection. When we look at Rome's legacy, we are not simply seeing ruins. We are witnessing the infrastructure that made an empire possible and allowed its influence to echo long after its political authority had faded. Rome's greatness did not emerge in isolation. It grew from a long conversation with the civilizations that came before it. When the Romans began to expand beyond the Italian peninsula, they encountered cultures whose knowledge had already been refined over centuries. From the Greeks, they absorbed advances in mathematics and geometry. From the Etruscans, they learned techniques in urban planning, drainage, and monumental construction. From Egypt and the older civilizations of the Near East, including Babylon, they inherited traditions of surveying, hydraulic management, and large-scale organization. Rome did not deny these debts. Instead, it transformed them. Greek science provided a foundation that Roman engineers would later put to work on an unprecedented scale. In the 3rd century BCE, Archimedes of Syracuse articulated principles of hydrostatics and hydrodynamics that explained how fluids behave. These principles eventually shaped the design of reservoirs, aqueducts, and harbor works throughout the Roman world. The device known as the Archimedean screw, a rotating helical mechanism capable of lifting water, was employed in mining operations and construction sites where groundwater needed to be removed. Theoretical insight became practical instrument. Other Hellenistic inventors also left their mark. Ctesibius of Alexandria, active in the 3rd century BCE, pioneered the study of compressed air and developed early force pumps. In the 1st century CE, Hero of Alexandria described and improved upon such devices, including piston pumps that were used for raising water in both civilian and military contexts. Roman builders adopted these mechanisms where they proved useful, especially in large public works that demanded reliable water control. The Romans were not primarily concerned with celebrating invention for its own sake. They were concerned with whether a device worked, whether it endured, and whether it served the common good. Precision in measurement was equally essential. The Romans refined systems of land surveying that had earlier roots in Egyptian and Greek practice. Using instruments such as the groma, surveyors laid out straight roads across uneven terrain and divided conquered lands into orderly grids in a process known as centuriation. This methodical partitioning allowed for efficient taxation, settlement, and agricultural planning. It also ensured that roads aligned with clarity and purpose, linking colonies to regional centers and, ultimately, to Rome itself. Geometry was translated into geography. Underlying all of this was a philosophy that Roman writers described with the word utilitas, meaning usefulness. Architecture and engineering were not merely aesthetic pursuits. They were moral and civic responsibilities. In the 1st century BCE, the architect and engineer Vitruvius argued that buildings must embody firmness, usefulness, and beauty. Of these principles, usefulness stood at the center of Roman thinking. A structure justified its existence by serving the community, strengthening the state, and enduring through time. This spirit of disciplined practicality distinguished Rome from the cultures it inherited from. The Romans respected Greek theory, but they measured its value by results. They studied earlier hydraulic systems, but they expanded them to supply entire cities. They borrowed tools and concepts, then applied them across continents. In doing so, they demonstrated that mastery lies not only in invention, but in adaptation, organization, and scale. Rome's engineers were heirs to ancient knowledge, yet they were also its stewards, carrying it forward and embedding it in stone, water, and roadways that would outlast their own generation. At the height of its power in the 2nd century CE, the Roman Empire was bound together by a network of roads that stretched for roughly 200,000 miles, with more than 53,000 miles of those routes paved in stone. It is difficult to grasp that scale even today. These roads crossed mountains and plains, forests and deserts, linking Britain to Syria and the Rhine to North Africa. They were not scattered paths formed by habit. They were surveyed, engineered, and maintained as part of a deliberate imperial system. When Romans spoke of all roads leading to Rome, they were not speaking in metaphor. They were describing a physical reality. The construction of a Roman road began long before the first stone was laid. Surveyors carefully studied the terrain, seeking routes that would remain stable across seasons and generations. They preferred gradual slopes whenever possible, avoided marshland and unstable soil, and selected passes that offered the most manageable ascent through mountainous regions. Roman engineers understood that water was the enemy of durability. Drainage ditches were cut along the sides of roads, and raised embankments were built where necessary to prevent flooding. Their choices reveal a deep respect for geography. Rather than forcing a straight line at all costs, they balance directness with long-term resilience. The strength of these roads lay beneath the surface. Roman roadways were typically constructed in several compacted layers. A foundation of large stones provided stability, above which smaller stones and gravel were carefully arranged and compressed. In major routes, a paved surface of fitted stone slabs formed the top layer, creating a durable track capable of supporting carts, mounted riders, and marching legions. The very concept of layering became so closely associated with road building that it influenced language. The Latin term strata, referring to a paved layer, eventually gave rise to words such as strata in Italian and street in English. Even our vocabulary carries traces of Roman engineering. These roads served many purposes at once. For the military, they enabled rapid deployment of legions to distant frontiers. Supplies, reinforcements, and messages could travel with a speed that astonished contemporaries. Ancient sources describe how Julius Caesar covered remarkable distances in short periods of time, sometimes arriving before the messengers sent ahead to announce him. Such movement was only possible because a reliable infrastructure already existed. The roads also carried merchants, tax collectors, officials, and travelers. Grain from Egypt, wine from Gaul, olive oil from Hispania, and countless other goods flowed along these arteries. Markets expanded, cultures mingled, and provincial towns became integrated into a broader imperial economy. Administration depended on this mobility. Governors could correspond with Rome, imperial edicts could reach distant provinces, and information about unrest or invasion could move swiftly back to the center. In a world without modern communication, physical speed was political power. The ability to move troops or transmit orders faster than arrival meant the difference between control and chaos. Roads made the empire legible and manageable. Standing on the remnants of a Roman road today, one can still sense that quiet confidence. The stones, worn smooth by centuries of passage, speak of intention and endurance. These were not temporary expedients, but long-term investments in authority. The empire expanded through conquest, yet it endured through connection. In every carefully graded slope and every layered foundation, Rome laid down more than stone. It laid down the pathways of power. If Roman roads were the arteries of the empire, its bridges were the moments of courage where engineering met uncertainty. A river is never still. It resists, erodes, and remembers every flood. To build across it is to make a claim against nature itself. The Romans understood this challenge early, and over time they transformed bridge building into one of the clearest symbols of their technical confidence. In the earliest periods, Roman bridges were often made of wood. Timber structures could be erected quickly and dismantled just as fast, a practical advantage in times of war. The most famous example comes from 55 BCE, when Julius Caesar ordered the construction of a bridge across the Rhine during his campaign in Gaul. According to his own account in the commentaries on the Gallic War, the structure was completed in just 10 days. Massive wooden piles were driven into the riverbed at opposing angles to counter the force of the current, then bound together with horizontal beams to create a stable crossing. After leading his forces across, Caesar later dismantled the bridge, denying its use to potential enemies. The message was unmistakable. Rome could cross even the most formidable frontier and leave no trace behind. Another flexible solution was the pontoon bridge, assembled from boats fastened side by side across a river's width. A deck of timber was laid across the hulls, forming a temporary roadway strong enough to carry soldiers, animals, and equipment. Reliefs on Trajan's column and the column of Marcus Aurelius depict such floating bridges in military use. These structures were not intended to endure for generations, yet they demonstrate the adaptability of Roman engineers. Speed and mobility were often more valuable than permanence. Over time, however, the Romans refined a more enduring form. Stone bridges became the hallmark of Roman civil engineering, and at the heart of their success stood the rounded arch. The arch itself was not a Roman invention, but the Romans standardized and expanded its use with remarkable mastery. In a stone arch, wedge-shaped blocks known as voussoirs are arranged in a curve so that each stone presses against the next. At the center sits the keystone, locking the structure into equilibrium. Instead of forcing weight straight downward, the arch channels it outward along the curve and into the supporting piers. This distribution of force allows for wider spans and greater resilience. What is most striking is the precision with which these stones were cut and placed. Many Roman arches were constructed without mortar, relying on the exact fit of each block. Temporary wooden frameworks supported the stones during construction, but once the keystone was set, the structure became self-supporting. The result was both elegant and strong, capable of withstanding the pressures of water, traffic, and time. Across the empire, remarkable examples still testify to this achievement. The bridge at Alcantara in present-day Spain, completed under Emperor Trajan between 105 and 106 CE, rises approximately 82 meters above the Tagus River. Its 6 arches span a dramatic gorge, and the bridge remains in use nearly 2 millennia later. Not far away, the bridge at Augusta Emerita, now Merida, extends roughly 722 meters across the Guadiana River. Originally composed of 60 arches, it was constructed soon after the colony's founding in 25 BCE and remains one of the longest surviving Roman bridges. In Italy's Aosta Valley, the Pont Saint Martin stands as another testament to Roman daring. Built in the 1st century BCE, its single arch stretches boldly across a narrow river channel. Medieval legends once claimed it was the work of the devil, a reflection of how astonishing its span appeared to later generations. In Rome itself, the Pons Fabricius, completed in 62 BCE, still connects the Tiber island to the city. It is the oldest Roman bridge in the city to survive in its original form, a quiet reminder that Rome often served as a proving ground for techniques later exported across the empire. Not all bridges endured. Floods, earthquakes, neglect, and the reuse of stone in later centuries led to the destruction of many structures. Rivers shift course, political orders collapse, and maintenance falters. Even so, the survival of certain bridges speaks to the quality of their construction and the wisdom of their placement. Built on stable foundations and maintained because communities continued to rely on them, they persisted where others vanished. Perhaps the most ambitious of all was Trajan's bridge across the Danube, constructed between 103 and 105 CE during the Dacian Wars. Designed by Apollodorus of Damascus, it featured 20 massive stone piers that supported a superstructure spanning a vast stretch of river. Though the upper portion no longer survives, ancient accounts and reliefs attest to its scale and ingenuity. It represented more than a crossing. It signaled Rome's determination to extend its reach beyond natural barriers. In every timber beam and every carefully fitted stone, Roman bridges expressed a broader truth about the empire. They were solutions to practical problems, yet they also carried symbolic weight. To span a river was to bind territories together, to shorten distances, and to declare continuity. The art of Roman bridge building reveals a civilization that measured its strength not only by the lands it conquered, but by the obstacles it overcame and the connections it made permanent. Beneath every Roman bridge and harbor lay a quieter achievement, one that rarely draws the eye, yet determines whether a structure survives a single season or many centuries. Foundations were everything. The Romans understood that no arch, however elegant, could endure unless it rested on stable ground. When construction required working within a river or along a shifting shoreline, engineers first confronted the problem of water itself. To create a dry workspace in the middle of a current, Roman builders employed enclosed barriers known today as cofferdams. These temporary enclosures were formed by driving timber piles into the riverbed and sealing the space between them with clay and other materials to reduce leakage. Once the barrier stood firm against the surrounding flow, the water trapped inside had to be removed. Here, practical mechanics came into play. Water-lifting devices, based on principles described by Archimedes, were used to draw out accumulated water, along with large water wheels capable of raising significant volumes. Through steady labor, the river was pushed back long enough for masons to reach solid ground. With the interior cleared, workers drove foundation piles deep into the substrate, sometimes using pile-driving mechanisms known in Latin sources. The goal was to anchor the structure to stable layers beneath the riverbed, rather than rely on surface sediment that might shift or erode. Only after this unseen framework had been secured could stone piers begin to rise above the waterline. The visible bridge, admired for its arches and symmetry, depended entirely on this concealed labor below. Yet the most transformative development in Roman foundation work was their refinement of hydraulic concrete. By mixing lime with volcanic ash known as pozzolana and combining it with aggregate, Roman builders produced a material that could harden even when submerged. When this mixture came into contact with seawater, chemical reactions formed durable mineral bonds that strengthened over time. This innovation allowed concrete to be poured directly into underwater forms within cofferdams, creating solid masses that resisted currents and erosion. The implications were profound. Harbors no longer needed to rely solely on naturally sheltered bays. Massive breakwaters and piers could be constructed outward into open water, expanding maritime capacity. Bridge foundations could be secured in deeper or more challenging river conditions. The scale of Roman port complexes and river crossings grew accordingly, not because nature had become less formidable, but because Roman engineers had learned how to work within it. What remains most striking is the balance between ingenuity and restraint. The Romans did not chase novelty for its own sake. They refined methods that proved reliable, combining careful surveying, mechanical devices for water removal, deeply driven piles, and concrete capable of curing beneath the surface. The grandeur visible above the waterline was matched by disciplined precision below it. In these submerged foundations, we see the essence of Roman engineering, a confidence built not on spectacle, but on mastery of the unseen. For a civilization that depended on grain shipments, maritime trade, and naval mobility, the sea was both opportunity and vulnerability. Rome's population, especially in the imperial capital, relied heavily on imported grain from provinces such as Egypt and North Africa. To secure that lifeline, harbors had to be more than convenient anchorages along a protected shore. They had to be engineered environments, stable against waves, currents, and time. The development of hydraulic concrete transformed what was possible. By combining lime with volcanic ash and aggregate, Roman builders created a material capable of hardening even in contact with seawater. This innovation allowed them to construct massive piers and breakwaters that projected outward into open water rather than clinging to naturally sheltered coves. Harbors could now be shaped according to strategic and economic need, rather than dictated entirely by geography. Concrete foundations poured within submerged frameworks formed durable cores that resisted erosion and sustained heavy maritime traffic. One of the most significant examples is the harbor complex at Centum Cellae, begun under Emperor Trajan in the early 2nd century CE, along the coast northwest of Rome. Designed to strengthen the capital's maritime supply network, the port featured substantial concrete moles and basins that improved docking capacity and protected ships from rough seas. The scale of the construction reflected Rome's understanding that commerce and stability were inseparable. A reliable harbor meant a reliable food supply, and a reliable food supply meant political continuity. Today, the modern port of Civitavecchia occupies the same site. Ships still enter waters first, structured by Roman engineering nearly 2,000 years ago. Though expanded and adapted across centuries, elements of the ancient foundations remain embedded beneath contemporary infrastructure. The continuity is not symbolic alone, it is physical. Layers of history rest upon the same submerged concrete that once supported imperial logistics. In these harbors, we see Rome's practical genius at its most expansive. By mastering a material that could endure beneath the sea, Roman engineers freed themselves from the limits of natural coastline. They extended land into water, reshaped maritime landscapes, and secured the commercial arteries that sustained the empire. Even now, as vessels arrive and depart from Civitavecchia, the quiet persistence of Trajan's harbor reminds us that Rome's influence was anchored not only in conquest, but in concrete laid against the tide. Behind the stone and concrete of Rome's great works stood a system of governance that gave those projects direction and continuity. Infrastructure on such a scale did not arise from improvisation. It required oversight, funding, and a clear chain of authority. The organization of that effort evolved as Rome itself changed from republic to empire. During the Roman Republic, responsibility for public works fell to elected magistrates. Officials such as censors, aediles, and praetors oversaw the construction and maintenance of roads, aqueducts, and other civic structures. Their duties were tied to public service and reputation. Successful building projects enhanced political standing, while neglect could damage it. In this period, infrastructure reflected a blend of civic duty and competition among elites who sought honor through tangible contributions to the state. With the rise of the empire under Augustus in 27 BCE, the center of gravity shifted. Emperors increasingly directed major building initiatives, especially those of strategic or symbolic importance, while provincial governors and appointed administrators managed local execution. The authority and vision often flowed from the emperor himself. Inscriptions carved into bridges, roads, and aqueducts sometimes preserve the names of these patrons, linking imperial identity to physical transformation of the landscape. Construction became not only a matter of utility, but also a demonstration of stability and legitimacy. Financing came primarily from the state treasury, sustained by taxation across the provinces. Yet private contributions also played a role. Wealthy individuals at times funded improvements or enhancements, gaining prestige within their communities. Public infrastructure thus combined centralized resources with local participation, reinforcing both imperial cohesion and regional pride. The labor that realized these ambitions was carried out largely by skilled workers, organized crews, and enslaved people. In certain military contexts, Roman legions contributed manpower, especially when roads or bridges supported campaigns. However, much of the enduring civil infrastructure was the product of coordinated labor forces operating under technical supervision. Their names are rarely recorded, yet their work endures in stone. Through structured administration, reliable funding, and disciplined labor, Rome translated political authority into lasting form. When we look at the remains of Roman roads, bridges, and harbors, it is tempting to see them as relics of a vanished world. Yet their true legacy reaches far beyond antiquity. Rome demonstrated with unusual clarity that political authority depends on infrastructure. Control of territory was inseparable from control of movement. To govern effectively meant to ensure that troops, officials, information, and resources could travel with reliability and speed. In this sense, the Roman state anticipated a principle that still shapes modern nations. Power rests not only in laws and institutions, but in the networks that allow a society to function. The vast system of Roman roads offers a clear example. Long after the Western Roman Empire declined, many of these routes continued to guide patterns of settlement, trade, and communication throughout Europe. Medieval towns rose along former Roman corridors. Pilgrims, merchants, and armies followed paths first surveyed by Roman engineers. Even in regions where the original paving stones disappeared, the alignments often endured. The physical imprint of Rome quietly structured the geography of later societies. Speed and logistics were central to this endurance. Ancient writers observed with admiration how quickly Roman leaders could traverse great distances. Such mobility was not a personal talent, but the product of infrastructure already in place. The capacity to move rapidly meant that authority could be asserted, defended, and coordinated across vast areas. That lesson was not forgotten. Modern states likewise depend on transportation networks and logistical systems to maintain cohesion. The Roman example reveals how deeply these practical foundations shape political reality. Yet the legacy of Rome is not confined to surviving stone or measurable mileage. It lies in a mindset that treated engineering as an instrument of order. Roman builders approached the landscape with discipline, precision, and long-term vision. They understood that durable construction reinforced social stability and that technical knowledge could serve collective strength. Their achievements remind us that civilization is sustained as much by planning and maintenance as by dramatic events. Standing today on a fragment of Roman pavement or beneath the shadow of an ancient arch, we are not merely encountering ruins, we are encountering a philosophy made tangible. The empire has long since passed, but the idea that infrastructure undergirds political and social life remains. In that sense, Rome endures not only in stone and concrete, but in the enduring connection between engineering, organization, and the structure of power itself. The empire that once ruled the Mediterranean has long since faded, yet its roads, bridges, and harbors continue to whisper their story. Rome reminds us that power is not sustained by conquest alone, but by the patient work of building connections that last. Thank you for spending this time with Echoes of Civilizations. If this journey deepened your understanding, we invite you to subscribe and return as we continue exploring the enduring foundations of our shared past.